Hello guys, welcome to another video of May the Codes Be With You, and today we are doing the unique paths 2 problem from Leetcode. It is a medium problem and it states that a robot is located at the top left corner of a m cross n grid. The robot can only move either down or right at any point in time. The robot is trying to reach the bottom right corner, so it can move left or right, down or right, and it has to reach this finish point in an m cross n grid, and we have some obstacles added to this grid. So you can pause and try this question yourself first. The link is in the description. So let's see the example and see what this question is basically saying. So we are given this m cross n 3 cross 3 matrix, and we have 1 in the middle, and the output is 2. That is, we have two paths. So let's better understand this example. Okay, so our robot is here at 0, 0, and our finish point is here at 2, 2, and we have an obstacle 1 in the center. So let's start from here and see the unique path. So here, this is our first path. Now this is the second path, and there are aren't any other paths. So 2 is the total number of paths. So let's see another example. So if we replace this one with 0 and place an obstacle 1 in the corner here instead, so let's count the number of paths. So one path could be from here, and another from here to here, another just right, left, down, sorry, now right, down. So we have gotten 4 paths. I can see one more here to here. So there are 5 total number of paths. So let's code this question, and I'll explain you my approach while coding it. So let's first solve for the boundary case when we have an obstacle at the last finish point. So we cannot have any case from here as our finish point is blocked by an obstacle. So let's change the name of this obstacle grid as array, because we'll need to write it again and again, so it will be easier. So if array dot length, so first we will write the boundary case when the last cell has an obstacle, and we'll return 0. So array dot length minus 1, array 0 dot length minus 1 cell. If a 1 is present there, so we'll simply return 0, and we don't need to solve it further. And now we will write the recursive function called utility. It is a kind of utility function. So return util, we'll name it util, and we'll pass the array, and I and j. So that's it. Now let's define our function util. So public, it will return int our grid array, whatever you call it, and then our ith position and our jth position. Sorry, we'll pass 0, 0 here. We can move right or downwards. So when we move right, we increase the ith value, and when we move down, we increase the jth value. So we will call recursive function calls for our moving right case and moving downwards case. So array I plus 1 and j, and this is the right one. Now we'll call for the downwards one. which is util array I and j plus 1. So this is the function calls, these are the function calls. Now we'll write the base case. If I equal to array dot length minus 1 and j equal to array 0 dot length minus 1, then we'll return 1. That is at the last, we are able to reach the last position. And if we are not able to reach that last position, that is our ith value has increased more than or equal to the length of the grid, then we'll simply return 0. 0 dot length, okay. So our one more condition would be, if we land at a obstacle position, that is array ij equal to 1, we'll return 0 as there is no path from there. So that's the recursive code. Let's run it. Okay, we have an issue. So okay, I have not used or there. Let me just correct it. Okay, or now run it. It is accepted. So this solution will return TLE error as it is not optimized and the complexity is 2 to the power n. So we'll use dynamic programming solution, and we simply have to just pass another array, dp array, which will store our values or solutions to that point. So it will be equal to array dot length plus 1, array 0 dot length plus 1. Sorry, it should be before length, array plus 1. Okay, so this is our dp array. Now we have to change our function calls. We will write dp here in the arguments of the function definition, dp here and dp here. So we will store all the solutions. So when we return 0 for obstacle, we will store that ij, dp ij equal to 0. Similarly, this dp ij, we will store the function call solution. And now we have to check if we have previously solved or not, and we can do that by seeing if the value of dp ij equal to 0 or not. If it is not equal to 0, we can simply return dp ij, which means we have previously solved this problem for this combination of I and j. Let's run our code, and it is accepted. Okay, let's submit it. Okay, so it is accepted. So it is not one of the fastest solution, but it is one of the most convenient solution, and we can solve many more problems like this from the solution. So thank you guys, and may the codes be with you.